have never given a talk in 15 minutes in my life. I usually spend 15 minutes introducing myself. So my name is Mike Coleman. I'm a staff developer advocate at Sysdig. I came over about 4 months ago from Google, where I led the GKE developer advocacy team. Before that, I was at AWS. Before that, I was at Docker. Before that, I was at VMware. So I've been doing containers and virtualization for about 15 years at some pretty good companies. And today, I want to talk to you a little bit about runtime security, specifically a project that we instantiated and donated to the CNCF called Falco. To talk about runtime security, I want to go back in time a little bit to when we worked on systems that were within well-defined perimeters. They were in a data center. And the idea of security was generally this idea of a firewall and IP rules and being able to keep people from getting into your system, right? That isn't how it is today. Today, we live in a world where there really isn't a perimeter if you're running in the cloud. If you haven't done it before, a fun exercise is to spin up a EC2 instance or a GKE instance or Azure instance, whatever it is, on the internet with a public-facing IP and measure how long it takes for people to start hitting that public IP and trying to break into your system. It's minutes, if not seconds. There's no idea of this big perimeter around our stuff. Everything's out there for you, and it's much more complex, right? There's ideas of IAM, identity and access management controls, network policies, the Kubernetes RBAC, all of these different things. I was giving a talk the other day, and a gentleman said to me, the most dangerous person to my environment is the disgruntled employee. And he or she does something because they're angry. And I said, I disagree with you, sir, respectfully. The most dangerous person in your environment is an overworked system administrator who's going to make an innocent mistake. How many of you have ever committed your cloud keys into GitHub? Yeah, raise your hand, because you've done it. I've done it. How many of you have ever over permissioned an object, full access on an S3 bucket, right? You do it. Why do you do it? Because it's easier, and I'm busy, and I don't have time, dude. I'm installing this thing, and it tells me to put these permissions on, and I don't have time to go through 45 permissions for an S3 bucket to figure out the 6 that I need, right? And so you say, all right, I'm just going to follow the instructions, because it's the easier way to do it. And you're not malicious, and you're not trying to break into the system, but you've now left an opening for somebody else to do it. Right? We have operational best practices. We have things that we're supposed to do, and most of the time we do them, but sometimes we get tired, sometimes we forget, and sometimes we take shortcuts, right? And that is actually some of the more dangerous activities that happen. And so when you have a wall and you are trying to keep people out, what do you use when they're already inside? What's going to tell you what's going on in your environment? In the physical world, that is a security camera, right? So you put a security camera up, someone scales the wall, you see it, maybe you have facial recognition, you decide if they're friend or foe, you can see if they're trying to break into the house, what they're doing, right? You have all these things that can send you an alert to your phone. If you've got one of those Ring camera things on your doorbell that always catches cool videos that end up on TikTok, whatever TikTok is, I don't know. I am way beyond the TikTok generation, people. Anyway, so we got the security camera, right? And it's kind of checking things out. So it works in concert with the wall. You've got the wall, it keeps people out, but someone got in or they were already inside. Maybe one of your kids is upset, you took away their TikTok. I don't know. So that is the idea of runtime security. So why do you even think about it? Don't we have things like CNAPS and CIEM and SAST and SBOM and all of these things, right? And a lot of those things are aimed at ensuring that what you put into your environment is as secure as it can be when you deploy it. So you write an application and you're scanning all your libraries and you're scanning all your container images and you're making sure your supply chain is, your CI/CD pipelines aren't compromised. And you get to this point where you've digitally signed this artifact, and you say, I know exactly what this is, because we had all of this stuff, right? And I'm monitoring it, and it's all looking good. How do you know what happens the next day? How do you know that someone didn't go in and shortcut and install a binary into that running container? How do you know that they didn't do something they weren't supposed to do, right? So there's this idea of sort of, we have the static analysis, static vulnerabilities, that sort of stuff, and then we have this idea of runtime security, looking at things as they're happening. The other part of it, too, is about not waiting until there has been a breach. So how did you know when someone got in through your firewall? Well, they did something, right? What you want to know is what are the things that people do leading up to an attack? So if I got into your container, into your system, the first thing I might do is install some command line utility or nmap or something, right? So what I really care about is knowing when that happens, because that is the first sign that something bad is about to happen, right? There's this idea of an attack framework where attackers go through explicit steps. You want to get into that as early as you can, right? So that's looking for unexpected patterns. So it's a combination of deploying secure software and then making sure that stuff is operating the way you expect it to. And so, if you look at something like Log4j, right, that was a vulnerability that was documented 9 years before people discovered it and fixed it. It was in people's, it wasn't documented, it was introduced 9 years before it was fixed. That's why you know that whatever you do on Tuesday may not be good on Wednesday, right? So, all right, so what is Falco? Falco is an open source project. We have, it was created initially at SysDig. We have donated it to the CNCF. It is incubating. We hope that it graduates. It has about 6,000 GitHub stars, and I guess I need to update my slide. We have about 60 million pulls of our image on Docker, from Docker Hub. It's being used at some big companies. I can't tell you the big company, but you might know them. One of our maintainers works for Apple. Might be a coincidence. I don't know. So big companies are using it in production to scale it out and protect their environment. So how does it work? So it only works on Linux systems, right? So for folks out there with Windows, unfortunately it doesn't work. What it does is we install a driver into the system. And we have 3 drivers. We have a loadable kernel module, we have an eBPF probe, and we have a modern eBPF probe. Yeah, I know, right? But the modern eBPF probe requires a more modern kernel because it uses like the CORE and some other stuff in there. I'm not an eBPF guru. I just know we got 2, and yeah. Anyway, so we got those things are happening, right? So they're monitoring at the kernel level system calls. Right? So anything you do in an application results in a system call. If you want to read a file, right, that gets translated into an open sys call, and then a read sys call, and then a close sys call. And those system calls are how the kernel goes in and says, okay, well, I have to go to this disk here, and I have to do this operation and return this data. So we look at those system calls. They get written into a ring buffer, not that you care, but they do, and we're just collecting them. And then we pass them up from kernel space to user space. This is a non-blocking operation. It happens almost instantaneously. We dump them on the ring buffer so that the kernel can go back to processing all the other stuff it needs to do. Then we have running in user space our command line utility. Oddly enough, it's called Falco. And it's comprised of a couple libraries, and what it's doing is it's taking and forming an image of your system, right? So it knows like what file descriptors matched with which file name. It knows when files are closed so it can remove them and you don't have to worry about them anymore. It knows that, well, that's super weird. There's a logo in there. You guys can see it. You can vouch for me, right? Well, there it came back. Okay, cool. How did that happen? Nope, it wasn't the clapper. I was just making sure. Anyway, so Falco's in there, and so that piece, it's a couple of libraries. It maintains something called a state engine, so we know what's going on in the system. And then it goes in, and we don't care about every system call. There's about 300 system calls in Linux. We don't monitor all of them. That's the first thing it does. It goes, do I care about the system call? This is the event parsing. No, I don't. Okay, I do care about the system call. All right, well, now I've got a list of rules, and I've got to go and see if this system call violated a rule. And we'll talk about rules next. And then if it did, I got to do an output message. And by default, we can send messages to standard out, syslog, HTTPS, and gRPC endpoints. So the reason this is so great for containers is that containers are an isolated process. Everything a container does across the system gets loaded, gets funneled down through the kernel, right? And so the kernel driver running on the host can capture all the activity inside the containers and running on the hosts. So you can install this in Kubernetes as a daemon set for the CLI piece, and that will run on each one of your nodes, and then it will install the kernel driver into each of those systems for you. In 15 minutes, I can't go much deeper than that. Okay, so we do system calls, but we also have a full plug-in architecture to extend it. So you can monitor things like GitHub and Okta and Kubernetes audit logs and AWS CloudTrail and GCP. So you can look for things like, hey, did someone just push an AWS secret key up into your repository? Falco can look at that for you, right? They can look at like, oh, did somebody fail their multi-factor authentication on Okta multiple times? And we can alert you to that, right? Did, anything, well, you get the idea, you get the gist. So there are about 80 rules that we ship with. And you can write your own rules, you can disable our rules, you can augment them, whatever you want. We do things, like I said, privilege escalation. Did somebody run a privileged container when they weren't supposed to? Did someone shell into a container and write something into a directory they shouldn't have? Did somebody change something in the environment? Did somebody take an application and rename it and move it? Right? Is somebody doing something that looks like it could be kind of weird? Right? And then we will let you know about that. So this is what the output message looks like. Did it work? Yeah. That is the wildest thing. It's not a build, I swear to you. Anyway, there's heavy congestion on the HDMI network today, apparently. Anyway, so that is the output right there. You can see on the top one, notice a shell was spawned in a container. We'll tell you what user did it, what their login ID was, the name of the container. We do that through a process called enrichment. We can build that state table of all the stuff going on in the environment. We don't just do it for the Linux system calls. We also do it by querying the Kubernetes API server and the container runtime. So by doing that, we can give you something more meaningful than file descriptor 3 was accessed by, AB17943X1 or whatever. So we have warnings and notices and criticals and all kinds of different things of those 80 rules. So by default, we'll take syscalls, we'll parse those out. We can also do the plugins that we mentioned about, and then on the output side, we have something called Falco Sidekick. And yes, it is one word. It was written by a French guy. Maybe that's why, I don't know. There should be a space there, but there's not, I assure you. It's not a typo. Otherwise, you're going to blame me. So Sidekick basically lets you take the output. We mentioned HTTPS, syslog, standard out, all of that. Lets you send it out to a whole bunch of other places, including the dude with the blue suit on. Somebody told me what that was yesterday and I forgot. But we can send it to chat programs. We can send it to logging, streaming, and queuing. We can send it to functions as a service. We can send it to Prometheus, Grafana. We can send it to storage buckets, right? Because you don't want to have to look at the log file every time to see what's going on. You want to be able to process it. And with that, you can take those outputs, ship them out into a function. So let's say that somebody executed a binary in a container that wasn't part of the base image. You could capture that event. You could then forward that to Lambda or Kubeless or OpenFAS or whatever, and you could write a little program that said, oh, that container was something weird happened. I'm going to pull it out. I'm going to tag it so I can quarantine it. I'm going to pull it out of commission, and then Kubernetes will start a new one. Then you can go do forensics on that. When we talk about detection, we talk about detection and response, right? We are detection. The response is stuff that you will build into the systems that you're already using, right? So 29 seconds left. Oh my gosh, you know what? I don't rehearse my talks either, so look at that. Okay, so falco.org, github.com/Falco Security, on Kubernetes Slack, #Falco. I'm in there as well as all the maintainers. We do a weekly community call at 4 o'clock in the morning, your time. 2 in the morning. Please join us, all of you. We are on the LinkedIn community as well. You can find all of our stuff there. We always are looking for new people to join the community, so please do. Thank you very much for your time, and I am over by 5 seconds.